Okay, let's start again. Any questions about yesterday? None? Good. Okay, let's continue. So yesterday I was finishing with the client-server model. One of the things that I think is important that you remember is this second bullet over here. If you have a client-server model where the client is waiting for a response from the server, you have an obligation to handle failures instantly, which can be a very important restriction. Actually, it requires special solutions. Now, you don't have this in the messaging system. Any more people out there? No. Okay. You don't have this in a messaging system because this is really a form of asynchronous communication. That means you send a request, and even if you are going to wait for an answer, there is no obligation from the system to instantly come back, whatever instantly could mean, of course. And the model is actually very simple. I'm going to try to see if I can use this thing again. It aims indeed at a persistent asynchronous communication. Processes send each other messages. They are queued. So your communication middleware actually has storage capacity. As a sender, you're not going to wait for a reply. Do other things. Well, you have the obligation to at least start to do other things. And like I said last time, IBM actually uses their message-oriented middleware to provide guaranteed delivery. Okay. And then suddenly this thing doesn't work anymore. It just works. I'm going to stop with this. This is a type of gadget that I'm not very happy with. Okay, this is better. What I first want to do right now, so I sketched the two types of communication, client-server versus message passing. I'll come back to actually implementation of message passing later on, but I now want to switch back to the canonical example of client-server communication as it is supported by the middleware. Okay, and these are remote procedure calls. And we'll be talking at length actually about these things. Oh, by the way, this is a small remark. Sometimes my slides look a bit, not weird, boring, I should say, like things like these. I did this on purpose because the slides have a one-to-one mapping with the structure of the book. So when you take a slide, you know exactly which part of the book that slide corresponds to. Okay, so I don't have to apologize for this boredom. Okay, let's take a look at remote procedure calls. Now, an interesting observation here is you see that the client server, this is the normal behavior. You have a client that wants to get something done. So in principle, it sends a request to the server and later on gets a reply back. And as I argued, I think it was yesterday, this client server model is a very natural way of how you actually engineer big software systems. We do this by means of modularization, and you put procedures or functions into a module, and what you do is you call these procedures or functions. And the essential reasoning behind remote procedure calls is, why can't I place that module or that procedure on a different server? And of course, there's fundamentally no reason why you couldn't do this. And that led to the concept of a remote procedure call, and it actually took quite some years before people actually completely understood what was needed to make this work. So the observations are like this. Application developers are familiar with this model. That's good, okay? We already have these well-engineered procedures that operate in isolation, and why can't you just place these operations somewhere else? This is a conclusion. The communication between the caller and the callee should, in principle, be completely hidden, hideable, I should say, using procedure calls. And then the only trick is, how do I make sure that a call translates to message passing across a network? That's the whole idea. And that means that a client will now call a procedure, under the hood a message is sent. And to make it even more interesting, for the server you just have your normal procedure, which is then called automatically, and I'll explain the automatically in just a minute, after which when you finish the call, a message is sent back to the client and translated to a return from procedure call. Okay? And here it is. That's big. Yeah. This is something you should understand, and if you don't understand it instantly or initially, you have to learn it by heart to make sure that you do understand this. I will explain how this could work in practice. Suppose I have a procedure called add, and this is a great procedure. It adds 2 integers and it returns the result. And this is a really super duper procedure. And, you know, it's really fantastic if you run it on my server. And what I want to do is I want to make this procedure available to clients. So the interesting thing is I don't want to tell clients about the implementation of my super duper add. The only thing I want to provide my clients is, hey, this is what you need to do. You need to call this function add I, j, and I will give you back k. Okay? And I will provide an implementation for that function. And in the meantime, I just want to make sure that anybody across the whole internet will be able to call this function. So what I do is, I also make sure that a client can call exactly this function. So I will provide an implementation of my interface on the client side, because I'm only giving the interface to my clients, and the interface is call this function add ij. Okay? You are all familiar with the concept of interface. What's your favorite programming language? Is Java for some of you your favorite programming language? No, that's actually a very wrong question. I'll just get very mundane. How many people have programmed in Java? Good. Then if you just take a class specification, that's an interface. Okay? And the actual realization of your headers or whatever you want to call them, that's my implementation of add. And in terms of Java, the trick I'm going to apply is I'm going to provide you at the server side and at the client side with exactly the same headers, the prototype in C, but I will give different implementations for both sides. And the implementation on the client side is call add ij, and under the hood, that implementation is just going to transform that into a send and receive statements communicating with the server. Okay? You have to realize this. So from an application point of view, you just see an ordinary call. And it's not that ordinary, but we'll get into the details later on. So what happens on the client side is the following. You have this interface in your Java class specification, and that thing is then marshaled, as it is called, into a message. And this message contains a field with, hey, this is about the procedure add. Okay, and I did this as a string, but it could be an identifier, it could be anything. As long as it identifies this procedure add. Oh, and by the way, I'm sending you 2 parameter values, namely the value I and the value j. Okay? You put this in a message, you pass it on to the operating system, it is sent across the wire or wireless to the server, and now this message is over here. Where it will then be unmarshaled in one way or the other, and then after the unmarshalling, what will happen is that this code that is dealing with this message will actually call this local implementation of add. Interesting observation, this interface, which is called by the client to this local implementation, is exactly the same as this interface, which is called from this piece of code to the implementation available at the server. So far, so good? And then you can imagine what happens. The implementation at the server side produces this magic value k, which is I plus j in this case. That result is marshaled into a message, sent back to the client, where it is then unmarshaled and handed back to the client application. And handing it back to the client implementation is done by means of a simple return statement. Am I making sense to you? So who am I not making sense? Okay, so everybody can write this piece of code. Who's in doubt? At least one person's honest. So I can't record the following, but I'm just going to use the Blackboard for this. There's a very simple way to see how this works. I will make a procedure. I don't know which language this is going to be, but that really doesn't matter. IJ, and it's something like return I plus j. Okay? That's it. That's my nifty implementation on the server side. I can't make it any simpler. On the client side, I have my procedure, add ij. And what do you think that will look like? That's going to be impossible. Okay, so let's get into the details. Why did I say that a statement like call, add doesn't make sense here?
Oh, because you don't know who to call.
That's one thing, you don't know who to call. What else?
You're already in this.
Hold it, what?
You don't know. You don't have your stubs ready yet, so you have to build the stubs first, like set up a connection.
I'm building the stub here actually. So what's in this stub? You're using a word that I haven't used yet, but that's okay.
What's in it? It's the location of the server.
So that's one. It's the location of the server.
I believe the functions that you're able to call.
Oh, you're getting too many details. Stay at the right level of abstraction. What is the only thing that this client has to get the server to work? It's really not much. It has a socket, means it has send and receive statements. Okay? That's what I wanted to hear. So it will be something like this. You build something like a message, and the message dot procedure is add. Okay, and the message dot value 1 is I, and message dot value 2 is j. Okay, and then you do something like this: send, and let's assume I know the IP address of the server. Send server message, and then receive from whom? Well, actually, the server a response. Okay, let's just make this a by reference value, and then I could say something like return response dot answer. So far, so good?
Where does the marshalling take place?
I would argue this is the marshalling. Okay, what I'm skipping are all the details about how to make this architecture independent marshalling. Okay, we'll get to that in just a minute. Okay, but it's now the principle that I want to make clear. Many people have some difficulties of understanding, I'm sending messages, but wasn't this a procedure call? And what I'm saying is, you do something like this, and there's more to this, and you have this return statement, and suddenly you transferred a call to send receive statements, and the receive is then translated again to a return statement. And what you will see on the server side is when this thing comes in, so this is really the implementation, okay? I'll call this thing the local add. And then what you will have is something at the server side, and let's just call this the sadd or something like that. And what it does, it receives this message, okay, from anybody, just let's say the first client that actually called this thing. And what I do is I read the message, and it would be something like, let me see, this is really bad, but don't worry about this. What I'm trying to indicate here, that this is a pointer to a function after I translated a string to a pointer to a function. Are you still with me? This is really bad because these are two strings over here, but I want to gloss over the details. So this is a pointer to a function, and by magic I translate this. Why do I babble? Why don't I just write string to a function message.proc. Okay, so that solves the whole problem. And you can imagine the implementation of string to function. So now you know what to call, and then it's now I have to think. It's something nasty like this in C, and then I'll do it like this. So now you get a k. You call this function with ij. You get your result back. This thing points to that, to the local add. And then what you need to do is, what I had response over here, response.answer is k, and then I send to the, I'll just say client over here because I had to pick that up over there, the response. End. That's it. That's simple, right? Normally there are a few bit more lines of code over here, but that doesn't do anything about the principle. The most important thing is that you see that you actually translate a call into send-receive statements, to a call, back to send and receive statements, and that's it. Okay? Is this clear to everyone? Now, what's the good news? From a middleware perspective, you only need to specify these interfaces. And there are a bunch of tools that, provided your specification of this interface is sufficient enough, is complete enough, you push a button and this code is generated automatically. Okay? So you don't have to write this down. Otherwise, hey, you're not getting any support. You just give this interface specification, you pass it through a so-called compiler, an IDL compiler, interface definition language compiler, and that stuff is then generated for you automatically. Very good. If you send me that picture, then I can put it on the web as well.
I hope it's good enough.
We'll see. There will come a time that I actually put what I just wrote on the blackboard. This is all magic when you, of course, listen back to the recordings. That I'll put it on the slides. Okay. Now let's think a bit about the nasty stuff. Parameter marshalling. So you have to realize you have to send stuff over the net. Okay? So in many cases that's okay. In just so many cases it's very wrong. It's very undoable. So there's more than just wrapping parameters into a message. One thing that I already mentioned last time is that the client and the server machines may have different data representations. Think of byte ordering. This is where I told you that if you take a look at the OSI stack, you have this presentation layer. The presentation layer takes care of that. And I argued the presentation layer is part of the middleware. Here you have it. It's part of the middleware. Any parameter needs to be transformed into a sequence of bytes. Are these 2 or 4 byte integers? Okay, you have to agree on that, and then they have to be transformed into something that you can put into messages. And what you just mentioned is that, hey, does this work like this? No, there's lots of code to do this transformation. One that comes close is this string to function. It could typically be something that you would find in a library in the middleware. And also very important, the client and the server have to agree on the same encoding. Basic data values, but the more complex ones are the let's say, arrays, records, unions, lists, etc., etc. So this is where it's going to hurt. And then they need to properly interpret the messages, meaning that the bits that they come in, I mean, we're all talking about bits over here. Don't try to interpret a 2-byte integer as a 4-byte integer. You can do this, yeah, but you'll get something else. Okay. Now there are a few assumptions. And there's one very, very important one. And the assumption here is that in your remote procedure call, you are assuming so-called copy-in, copy-out semantics. And copy-in, copy-out semantics is like this. I call a procedure, I throw parameter values into that procedure, and they're out of my control domain. Okay? They belong to the procedure. So the procedure can do all kinds of stuff with it, and then it will throw back results at me. Okay. How many languages do you know actually follow these semantics? Does C follow these semantics? Think multi-threaded programs. Think about a procedure that blocks when it's being called. No problem done, you can start another thread, and then what? Can that thread modify, it's a really nasty programming, okay? But can that thread modify the parameters that you just passed to that procedure? For example, in C. It depends on?
In C, there are two types of passing parameters. You specify the value. The values are copying on the stack.
Uh-huh.
Thread and the stack. So it's belonging to you. But if you use pointers, the stack will contain the pointer, but the pointer will point to the same value.
Okay, exactly. So I would argue C does not. So it depends. I'll repeat the question, sorry, remark. So it depends on how you pass parameters. In C, you can do this by reference or by value. I would argue in C that you actually always do it by value, but that's because of the way that you look at pointers in C. But the most important observation is if you do it, let's say, if you take pointers, then you can start playing with that stuff even while the procedure is being blocked, and you would actually completely screw up. You may screw up what the procedure is actually working on. If you really pass things by value, hey, the stuff is pushed onto the stack, out of your scope, you can't play with that. But in general, languages do not copy in, copy out semantics. I only know of one language that does this. It's called Ada. How many of you have ever heard of Ada? Oh, I'm surprised. Okay. Well, if I would ask this question another 5 or 10 years down the road, I would be surprised that any of you ever heard about Ada. This was one of these great languages that was invented by a committee. It's not a bad language, by the way, but it's basically nobody's using it. Okay. All data that has to be operated on is passed by parameters. This is actually the crucial observation. Just a minute. This is a crucial observation. All the data that you need to operate on has to be passed to the procedure, which means that if you're going to operate on a tree, like walking through a tree, if you're doing a search operation, that whole tree will have to be passed to the procedure. For a very simple reason. If you're going to operate on a tree or any of these kind of dynamic data structures, the server will be out there and says, I don't know what you're talking about. I don't have this tree. You just gave me a pointer to a tree. That's nice. Where is it? It's not in my memory. So you have to pass the entire tree. Okay, you had a question.
Something about the copy and copy out. Could that in Java be enforced by synchronize?
Could copy in, copy out semantics be enforced in Java by means of synchronize?
At least that another process can't touch the variables that you're using.
I think the answer is no. What synchronize does in Java is that it protects the object to which the method belongs that for which you have specified the synchronize. So all the internal data into an object, that is protected. Not necessarily the parameters, which could also work on objects that are outside the object that you're calling. Those objects can still be modified even if you block inside the object. Do you agree?
I thought that everything inside that is declared or used inside a synchronized method is protected.
If I would, I thought not, but I may be wrong. I'm not a proficient Java programmer. If I would call a synchronized method in an object, and that method takes a reference to an object as a parameter,
That object also needs to be synchronized as well, unless the compiler wouldn't bitch about it.
okay, that's something else. Then it would be an enforced, but that means that if I would then call a method from that object that I just passed as a parameter, your claim is then all the methods that you would be able to call from that object should also be synchronized.
And this is enforced by the compiler.
And it's enforced by the compiler. And what would happen if you would have non-synchronized methods of an object?
That's fine.
That's fine. Which means it's not copy in, copy out semantics. Got it? Good question. Good remark. Okay, what do you see? Global references, pointers, those things are not going to work. Conclusion, full access transparency cannot be realized with remote procedure calls. Okay? A very important observation. It helps you a lot, but when the going gets tough, hey, you're on your own. A remote reference mechanism actually enhances the access transparency. I'm thinking, should I explain it right now, but I'm not going to do this. We'll be talking about object-based distributed systems. We'll come back to exactly this point, so kind of remember it when I talk about remote references, notably in Java. But there are too many tricks here that need to be explained before I can come to a decent explanation of that. Just as a forward reference, I will be arguing that you can also have too much transparency, so that too many things are being hidden, and that it may actually be very difficult to notice if you're working on local stuff or global stuff, and you would actually not mind at all knowing whether it's local or global. We'll get to that discussion when we talk about object-based systems. Okay. Now, this is just for the record. Once you have RPCs, it's a great mechanism, but then suddenly people say, hey, not good enough for me. So they come with all kinds of variants of RPC, and they give these things names like asynchronous RPCs. And what's an asynchronous RPC? Well, here's a potential model. This is the normal model, meaning that you wait over here until a result comes in. And an asynchronous RPC is you do the call, and you wait for an acknowledgement that the call has been accepted. Or you even just continue. We used to call this message passing. You also have deferred synchronous RPCs. You call a server, you almost immediately continue where you left off. You as a client continue to operate in parallel with the server, and then there are two variants. You ask the server whether the result is already in, or you get a notification from the server that your result is there. Okay? We also call this message passing twice, doing asynchronous communication twice. The reason why I'm mentioning these things is when you see these type of terminology pop up in books, you say, oh my God, is this something really new and nifty? And the answer is no. And then if you open up another document, you get another term for something that seems really fancy and whatnot. And after this course, you should be in a position saying, oh, wait a minute, what is this really all about? And it turns out that it's something you actually already knew. And I'm a bit nasty here. I just don't like what all these manufacturers of middleware are doing. they are throwing so many new things, new quote unquote, to us, and in the end, it's all stuff that we knew, okay? And I just want you guys to be aware of this. So if you see a new term, you get into this mode like, what do they really mean? And then in the end, in 90% of the cases, it turns out that it was not something new at all. It was something that you were taught way back then in a course called Distributed Systems. Okay, got it? Now, let's take a look at how you use remote procedure calls in practice. How many of you have actually used remote procedure calls? Very good. And are you referring to the Java stuff, the remote method invocation, or the Sun-based stuff with real RPCs in C? Java, okay. Both, very good, okay. Now that's actually very good. Oh yes, it's because it's a network programming. Yeah, very good. Okay, so this is all familiar to you, and except for those who did not take a course on network programming. Let's skip this part. You have an interface definition file. This specifies your prototype. You run this thing through a compiler, the IDL compiler, and what you get out of this is, let's say, a C environment is a header over here, a client stub over there, and a server stub over there. Okay? The header file is very important because this header file is used by the client code as well as the server code to actually make the call. On the client code, which is your application, you need to know what this procedure add looks like, right? And you get this information from the generated header file. You run your application through a compiler, you get your object code, you go to a linker, and then you link stuff that came out of the blue magically along with the runtime library, and you got your binary. Now, like I said, the IDL compiler also generates the stub, and this is just a piece of C code. You can read it. So here's my next question. How many of you have read the generated code from an IDL compiler? A few, but not enough. It's nasty code, okay? But it's readable. And what you could do is actually take preferably one of the very first versions of, for example, RPC Gen, which is the Sun tool, because that thing was not optimized, and it produces actual readable code. And what you'll find that it generates is actually something that is very close to what you would sometimes call a framework. It's a bunch of code, standard code, and you will see lots of pointers, and all these pointers are pointing to specific data structures related to what you have specified in the interface. But the most interesting scheme is, or the thing is, that you'll see send and receive statements that will be the same for all client stubs. So you've got to read a bit around those things, and then you'll see, hey, it really is a generated stub and just made specific for what I just specified in my interface. It's C. That means that you run it through a compiler, you get your object file, and then using the linker, that stub, this object file, and the runtime library linked together, you get your binary. What's in the runtime library? All the libraries that you include. Nope. I should have drawn an extra box. All the libraries that you include over here. Okay? And you're absolutely right. Those things, so there should be a separate box next to the runtime library that you link over here. That one's fine. But not this specific one. Okay, so what's in this library? And I just heard the answer. Who said that? Marshalling. All the compiled marshalling functions. And by marshalling, I now really mean the string to function. The string to integer, the integer to string, the string to network independent representation of whatever you want to have a network independent representation for. All these things are implemented in this runtime library. You link that, and these are the things that you actually call from both these two, actually, mostly from this one, and that's how you get your binary. And on the server side, you have essentially the same thing. The big difference is that where this is your application calling a function, this thing over here contains the implementation of the function that you're exporting to clients. And again, it's just C code, you run it through the whole stuff, and there you go. This should look very, very familiar to those who took a course on network programming. Simple, right? Okay. I think it's important that you know this scheme. It gives you a high-level view of what's going on in RPC, and what you'll see is that remote procedure calls in terms of middleware is a set of tools that will allow you to just give this interface over here, push a button, and there you go. And the work that you need to do is to write an application and to write the implementation of the functions that you're exporting to clients. And that's it. Okay? And it's all the same, also for Java. By now, I think Java is doing this automatically, but I think you used to have this stub compiler also in Java. Like I said, I'm not proficient in Java, actually. I never grew past the C phase, I'm afraid. Well, a bit. Okay. Yes? Why do you... What is, okay, actually that's a very good question. What is a stub? A stub is this part. The stub is the code that, I'll first look at the client-side stub. The stub is a piece of code that offers an interface, but that otherwise handles taking that call and transforming it into a message that you can then send to the server, after which it will receive wait until it receives an answer. This is a stub. This is a stub. And what I'm saying, very important, if I give only this specification, this single rule, I can push a button and then this code is generated automatically. Okay? But this is the stub. You compile the stub. And on the server side, it's exactly the same. I give this specification and it generates this stuff. Yeah? And that's called a stub. Got it? Okay. Okay. Now, this is nice. So you have a server over there, you have a client over there. Now you got to bind those two. And one that is kind of a common one, but it comes in kinds of variations, originates from the distributed computing environment. That's dead, by the way. Nobody's using that anymore, but the scheme is exactly the same. You have a machine, directory machine, it's running a server, and what you can do as a client over here is you know what you're looking for, so you look up at the server, hi, I'm looking for this great, fantastic procedure called add. And then what the server will provide you is information on where this thing is. Now, what is this information? I was the developer of this magnificent shouldn't try to use those type of words when I'm after a meeting. This great procedure called add. But I have to register it at the directory server. And what I do actually is I first register an endpoint. There's no magic to this endpoint. It's called a port. Okay? You all know this. If you start running something, you go to the operating system and says, give me a port, because then people will talk to that port. This is exactly the same as your FTP port, your Telnet port, your web port, all the same. You just get this magic number, the port, and you register that thing at the directory server. Okay? Oops, and then, you register the service. Now, what happens now is I was the client, I looked up this really nifty procedure add, I get an IP address back, contact the server, this so-called daemon will say, I know this procedure, I gave it port X, I returned that to the client, and now the client can do the actual RPC to that magnificent procedure. How do I get to know where this daemon is? What? Standard port, yeah. We generally don't talk about a standard port, but a well-known port. Well, it's subtle. It's terminology, no more than that. Okay? And that's it. Is this scheme clear to everyone? Okay. Any problems with this scheme?
Directory service dies, you've got a problem.
That's an interesting observation. If the directory server dies, you've got a problem.
Only for new
Only for?
clients. New clients.
Only for new clients. Which brings me to another interesting observation. Would you need to necessarily contact the directory server every time you need to do an RPC?
I think it depends. If the server machines change a lot, and you can actually have a middleware.
If the server machines change a lot, I'm just repeating your answer, yes, then it could matter, okay? And so your answer was also correct. So I was just thinking the next best answer to security is it all depends, okay? But in this case, your answer is correct. It depends, for example, on whether or not the server on which your great procedure is actually running changes a lot. If we can make the assumption that it doesn't change that often, then what you can do is you can tell the server over here, I'm running over here and I got a lease on my port saying that port is going to be valid for at least, you name it, 30 seconds, 60 seconds, an hour, which means that you can give that information back to a client saying, client, you don't have to come back to the directory server. You can cache this port number and try to see if you can directly then contact, tell the server, and then this guy over here will say, okay, you can keep this address for a while because I promise that I will keep this address up and running for a while. If it turns out that you can't contact the server for whatever reason, no harm done. You go back to the directory server to see what's going on. If the directory server will give you back stale information because something really big happened, then you're in trouble. But that's normal fault tolerance. Okay? Let me see what time we're doing. Yeah, this is a good moment to take a brief break.